One aircraft has defined commercial aviation for over 60 years. More than 10,000 delivered. Thousands more on order. Airlines worldwide built entire business models around it. But here's the question nobody wants to answer. Why can't anything replace it? The Boeing 737 was first designed in the 1960s. That was before the moon landing, before the internet, before personal computers existed. Yet it remains the backbone of global short-haul aviation today. More than 10,000 Boeing 737 aircraft have been delivered since the program launched in 1967. Thousands more are still on order. From low-cost giants like Southwest Airlines and Ryanair to major network airlines worldwide, entire business models are built around this one aircraft. This is not just another jet. The Boeing 737 is the foundation of modern airline economics, and that creates a problem Boeing cannot solve. The real story is not just longevity, it is dependency. Boeing has considered building a clean sheet replacement for the Boeing 737 for years. Engineers have drawn up concepts. Executives have run financial models. But every time, they stop. Why? Because replacing the Boeing 737 would cost tens of billions of dollars. It would require massive pilot retraining across the industry. It would disrupt airline fleets that have operated nothing but Boeing 737s for decades. It would force airports and maintenance networks to completely adjust. Think about what that means. The entire aviation ecosystem is optimized around the Boeing 737. Training simulators are built specifically for Boeing 737 cockpits. Spare parts, supply chains stock Boeing 737 components. Airport gates are sized for Boeing 737 dimensions. Crew certification systems are designed around Boeing 737 type ratings. Replacing the Boeing 737 is not just designing a new plane. It means rewiring the entire industry, and that creates massive resistance. Southwest Airlines operates over 800 aircraft. Every single one is a Boeing 737. The airline has flown nothing but Boeing 737s since it started operations in 1971. Pilots trained on the Boeing 737 can fly any Boeing 737 variant in the fleet. Mechanics know the aircraft inside and out. Gates fit perfectly. Ground equipment works with every plane. Now imagine Southwest buying a completely new aircraft type. Pilots would need months of retraining. New simulators would cost millions. Maintenance manuals would need complete rewrites. Spare parts inventory would require total replacement. Gate infrastructure might need modifications. The cost would run into billions. And for what? A slightly more efficient aircraft that disrupts everything that makes Southwest's operation work smoothly. Ryanair faces the same calculation. The Irish carrier operates over 500 Boeing 737 aircraft. Its entire business model depends on Boeing 737 economics and operational simplicity. Michael O'Leary, Ryanair's CEO, has publicly stated the airline will likely never operate anything except Boeing 737s. United Airlines flies hundreds of Boeing 737s. American Airlines operates a massive Boeing 737 fleet. Alaska Airlines just ordered 105 additional Boeing 737 MAX 10 aircraft in the largest narrow-body commitment in its history. These airlines are not ignorant. They understand the Boeing 737 is old technology. They know newer designs could offer advantages. But they also understand the cost of change, and that cost is astronomical. Even after the Boeing 737 MAX crisis and global grounding, airlines continued ordering it. This seems insane on the surface. 2 fatal crashes killed 346 people. The aircraft was grounded worldwide for nearly 2 years. Boeing's reputation was destroyed. Quality problems persist across the company. Yet airlines kept buying Boeing 737 MAX aircraft. Why? Because there is no easy alternative. The Airbus A320 family competes directly with the Boeing 737. It is an excellent aircraft. Many airlines operate large A320neo fleets, but the A320 has not eliminated the Boeing 737. It cannot. The market is big enough for both. More importantly, airlines that already operate Boeing 737s face enormous switching costs to move to Airbus. A pilot certified on the Boeing 737 cannot fly an Airbus A320 without complete retraining. The cockpits are entirely different. Flight control systems work differently. Procedures are different. An airline switching from Boeing 737 to A320 must retrain its entire pilot workforce. That takes years and costs hundreds of millions. So Boeing kept stretching, upgrading, and modernizing a 1960s airframe. The original Boeing 737-100 seated about 100 passengers. The Boeing 737 MAX 10 seats over 200. The fuselage has been stretched multiple times. Engines have been upgraded through multiple generations. Wings have been redesigned. Avionics have been completely modernized. But the fundamental design remains. The wing height off the ground is the same as it was in 1967. That low ground clearance created problems when Boeing tried to mount modern, larger diameter engines. The engines would not fit under the wings without modification. Boeing's solution was to mount the engines slightly forward and higher on the wing. This changed the aircraft's aerodynamic characteristics. It created the nose-up pitching tendency that required the MCAS system. That system design contributed to 2 fatal crashes. A clean sheet aircraft would not have these compromises. Engineers could design the aircraft around modern, large diameter engines, ground clearance could be optimized, the wing could be positioned ideally, systems could be designed from scratch using modern architecture. But doing this triggers costly certification resets. A new aircraft type requires complete FAA certification from zero. Every system must be tested. Flight testing takes years. Certification typically costs billions and requires 5 to 7 years minimum. More critically, a new aircraft eliminates commonality with existing Boeing 737s. Airlines lose the operational advantages that make the Boeing 737 valuable. Pilot commonality disappears. Maintenance commonality is gone. All the ecosystem benefits evaporate. So Boeing kept evolving the existing design. The result is one of the most continuously evolved aircraft designs in history, a jet that keeps adapting instead of retiring. This creates an interesting parallel. The US Air Force operates the B-52 bomber. That aircraft first flew in 1952. It will remain in service past 2050. The B-52 keeps getting upgraded with new engines, avionics, and weapon systems. But the basic airframe is 70 years old. Military aircraft stay in service for decades because replacing them costs enormous sums. The same logic applies to the Boeing 737. The aircraft works. Airlines know how to operate it profitably. Changing creates massive costs and risks. Boeing depends on the Boeing 737 program for survival. The aircraft generates most of Boeing's commercial aircraft revenue. The backlog extends years into the future. Canceling the program without a replacement would devastate Boeing's finances. But launching a replacement risks billions with uncertain payoff. If airlines do not buy the new aircraft in sufficient numbers, Boeing faces catastrophic losses. If the new aircraft has technical problems, Boeing repeats the MAX crisis. If certification takes longer than planned, Boeing loses market share to Airbus. The safer path is continuing, the Boeing 737. Keep making incremental improvements. Keep deliveries flowing. Keep revenue coming. Avoid massive development risk. This creates a trap. The Boeing 737 becomes harder to replace the longer it continues. More aircraft enter service. More pilots get trained on it. More infrastructure gets built around it. The switching costs grow larger. Meanwhile, the design gets older. Modern clean sheet designs offer advantages the Boeing 737 cannot match. Better fuel efficiency, lower maintenance costs, improved passenger comfort, more advanced systems. At some point, the Boeing 737 will become uncompetitive. But when? And what replaces it? Boeing has studied new aircraft concepts for years. The new midsize airplane, or NMA, was proposed to fill the gap between Boeing 737 and Boeing 787. Boeing ran the numbers. The business case did not work. The program was canceled before launch. Other concepts have been studied. A clean sheet, Boeing 737 replacement, an all-new narrowbody with revolutionary technology. Each time, Boeing concluded the risk was too high. So the Boeing 737 continues. Airlines keep ordering. Boeing keeps producing. The industry remains locked into a design from the 1960s. In the end, the Boeing 737 is not irreplaceable because it is perfect. It is irreplaceable because the world is built around it. Airlines depend on it. Boeing depends on it. And replacing it would risk billions. That is the real answer. Not why won't they replace it, but why can't they? The costs are too high. The risks are too great. The ecosystem is too established. Change would require coordination across the entire aviation industry. Airlines would need to accept transition costs. Boeing would need to invest massive sums. Regulators would need to certify new designs. All of this creates inertia. The Boeing 737 continues not because it is the best possible aircraft. It continues because changing costs more than staying the course. So the next time you board a Boeing 737, remember this. You are flying on a design that predates the moon landing. And you will probably still be flying on Boeing 737s 20 years from now. Not because Boeing wants it that way, but because the entire industry is trapped